Hello everyone, my name is Teacher Kels and I'm here to take you through Maths Lit during these difficult times. My background is stats and applied maths, so I know maths kind of well, but teaching is a totally different ball game during the lockdown, so hopefully we can cooperate and make this work. So today we're going to talk about graphs. You'll find this in your textbook on pages 200, 201 and 204. Now, graphs are supposed to make our lives easier. They take a whole lot of information and they summarize it into a nice picture form. So take a few minutes and look at this graph, maybe pause the video and then we'll talk about it. So the first thing to do when interpreting graphs is to look at the axes. We have a vertical axis which goes up and a horizontal axis which is flat. The vertical axis here is reading temperature and the horizontal axis here represents time of day. So what this graph is basically telling us is how temperature varies with respect to time of day. So we can see if we start at 0, that's midnight, we have quite a low temperature, and then as the day progresses towards noon, the afternoon, we get highest temperatures. So the highest temperature here is at 12 noon, and then the temperature tapers off as we get to the evening, as things cool down, and it gets low again at midnight, 24 hours. So points that we are usually interested in when looking at graphs are the highest point and the lowest point. Another thing we need to talk about are the independent and dependent variables. So these will be under the keywords in your textbook. So the dependent variable always relates to the vertical axis. The independent variable always relates to the horizontal axis. So if you're struggling to understand the relationship between the two, you can think about it like this. Basically, the temperature depends on the time of day. So this will become more clear as we look at more examples. So the first example I'd like to look at is on page 200. There's just one graph there. And if you read, it says the vertical axis is the value in rands. The horizontal axis is the time in years. And this graph is describing how an investment changes in value over time. So we can see this graph is going up. So it means the value of our investment is increasing as time passes, which is what we would expect in real life. So if you're thinking of dependent and independent variables, basically the value of the investment depends on how long you've had the investment for. Next, I want to talk about discrete and continuous. These are two other concepts you'll find in the keywords, and I'd just like to talk about them a little bit and describe them a little better to you guys. So when data is discrete, it means that it's countable. So countable in whole numbers. So examples of discrete data include if you're counting, say, number of people. You can have 1, 2, 3, 4 people. Continuous data is when you can get any value within a range. So in other words, continuous means you have fractions. Examples of continuous data are things like weight, where you can have like 64.5 kilos, temperature, 10.5 degrees, so we can get fractions in continuous. So how these different types of data show up in the graphs is that continuous shows as a smooth line and discrete will show as dots. So this example here, we have two continuous variables, temperature and time of day. Remember with time, even though it's showing hours here, 0 hours, 12 hours, 24 hours, time is continuous. You can have like 2.5 hours, 12 3/4 hours. So that's why this graph is shown as a smooth line. So for the discrete story, I'm going to make up a little example. So here I'm going to talk about selling packets of chips. So this is a case where one packet of chips sells at 2 Rand each. Okay, so these are 80s prices. I'm just using small numbers to keep it simple. So if we were to represent this as a graph, we would have number of chips sold as the horizontal and the income as the vertical. This is because income depends on number of chips sold. So you can't put it the other way around. So on this axis, number of packets sold, and on this axis, income. So this point here is called the origin. It's always 0 for both axes. So if we sell 0 packets of chips, we make 0 income. So sorry, just I'm putting down the units, income in rands. They like it when you're specific about these things. So 0 rands. Then I'll make up some values here. So if we sell 1 packet of chips, we make 2 Rand. If we sell 2 packets of chips, it's 4 Rand. 3 packets of chips, 6 Rand. 4 packets of chips, 8 Rand. Let me just make the dots crosses so it's clearer. So these are discrete data because we can't sell like half packets of chips. So that's why the representation here is a bunch of dots. Also, this is an example of a linear relationship. We'll talk about it a bit more in depth, but basically it goes up like in a nice straight line. The previous example of temperature was non-linear. So it had a shape like this. So moving on, I wanted to talk a little bit about the first question in exercise 18.1. This is talking about the temperature at the airport, and it's measured at noon every day for a week. So on our horizontal axis, we have the days of the week, Monday to Sunday, and on the vertical axis, we have the temperature in degrees Celsius. So because we're only measuring one temperature at noon, this would be discrete data. So we can see it's represented as dots. So going back to what we spoke about in the first graph, the points we're interested in are like the highest temperature and the lowest temperature, and if it follows any kind of linear pattern or not. So in this example, we can clearly see that the dots are spread around all over, so it's non-linear, it's also discrete, as mentioned earlier. So let's go through the questions. So for A, is this discrete or continuous? Why? So because there's only one temperature measured at noon, it's discrete, and also the days of the week are discrete. Okay, you can't have like halfway between Monday and Tuesday. It's either Monday or Tuesday. So what is the independent variable? This is B. The independent variable is going to be on the horizontal axis. So you would say those are days of the week. Next, what is the maximum value of the graph? This looks to be on Thursday, the 4th dot. Next, which is the coldest day of the week? This looks like Saturday. Next, what is the minimum temperature of the graph? So the minimum temperature and the coldest day of the week are going to be the same. It's quite obvious. So that's also going to be Saturday. So for F, on which day was the temperature recorded as being 30 degrees Celsius? So over here you have to read the scale on the vertical axis and just find 30 and then see which day of the week it corresponds to. So 30 on the dot corresponds to Tuesday.